Hi, everyone. So today we're going to be going over the muddiest points for the final exam. This is from the survey that was posted on Ed Discussion. Here's the list of topics that we're going to be covering. Just wanted to take a look at it really quick, but we're going to jump right in. So the first topic is we're going to be understanding the hypothesis test for linear regression and how to calculate the p-value. So the first thing that we need to do is look at the significance of regression. And this is from your guys' textbook, but it says the test for significance of regression is a test to determine whether a linear relationship exists between the response variable and a subset of the regressor variables. So basically, we're going to fail to reject H naught in the test for significance means that all regressor constants are equal to 0. So I have that listed out right here, but I'm going to list it up here too. So first one is going to be up to b to the k, and these are going to be equal to 0. And then we're testing that against h1, where one of these values does not equal 0. And so these values right here are going to be the subset of regressor variables. But an easier way to determine this is you need to look at the p-value in alpha. So if the p-value is less than alpha, then you're going to reject the null hypothesis. And I would recommend everyone go back to homework 21, question 11, and take a look at an example for this. It's a really good example. It's kind of long, but once you input the data into Excel, it'll be kind of easier. But like the basic idea to solve the problem is you want to add the values to Excel and then use the data analysis regression. And then one of the questions was how to find or calculate the p-value. The p-value is going to be on that chart. So once you input all the values and then calculate the regression, you'll be able to see the p-value. And then the next topic we're going to go into is the hypothesis test on correlation. So to do this test, first we need to find the correlation between some variables x and y, and this is going to be called R, and this is an estimator. We also need alpha, and then we need n, where I don't want you guys to get confused, but n is the size of like the number of variables, not the total number of samples. So for example, like say you have 17 samples in X and 17 samples in Y, n would be 17. And then this is just kind of the same thing for the hypothesis test of things you need to know. We're using the T statistic for this with 2 degrees of freedom. But now we're going to do an example on this. And I apologize for it being a little messy, but I'll walk you guys through it. But basically over here, this is the data for the example. And what I did was you're going to input the data into L1 and L2 in your calculator. And then you're going to run statistic, calc, and then linear regression of AX plus B. And then once you do that, you're going to get a bunch of values, but you're looking for the R value. And then this is going to be 0.933. And so if we use the formulas from the previous slide and we let alpha be 0.05, we can use T naught, which is equal to R times the square root of n minus 2 over the square root of 1 minus R squared. And then when we plug in our values over here, notice right here, this is n minus 2. And then there's 17 values right here and 17 values right here. So then that's going to be 15. And then the final answer for that is going to be 10.06. And then we're going to use the T statistic with 2 degrees of freedom. So we're going to do T of alpha over 2 of n minus 2, which is going to be T of 0.025 of 15, which is going to give us 2.131. And now we're going to compare if T naught is greater than T alpha over 2 and minus 2, and it is, so we're going to reject H naught. And I'll leave this up for a moment so everyone can see, and these slides will be posted as well, but in case you're following along, I'll just give it a second. Oh, and then also one final note is that you can run this regression model on Excel, and then you would be able to see that P is not equal to 0 if you wanted to test it for your own understanding. Okay. And then, so we need to understand differences. This is the next topic that we're going to discuss. So the question on Ed Discussion was, what's the difference between if we have mean 1 minus mean 2 not, and the mean difference. So if you kind of go through the homework, you should be able to kind of start to differentiate when to use the two. But basically, for mu1 minus mu2 is delta naught. We're looking between the difference between two corresponding sample means. So an example of that would be x bar minus y bar. And then I just added these in so that you guys don't have to go back and really look. But you want to use, when the variance is known, use the two sample z-test. And when the variance is unknown, use the two sample t-test. This is kind of going back, I think we went over this in the exam 2 Muddiest points survey of like when to use the z-test versus t-test, or the t-test statistic or the z-test statistic. So just kind of remember those concepts as you're studying for the final as well. And then the second part of this question was the mean difference. So this is going to be when you're finding the difference of every value, and then you're finding the mean. So say you had, or actually we'll do this. So you had list 1 in your calculator and list 2, and then there's some values in list 1 and some values in list 2. And then you can create list 3, which is going to be L1 minus L2 or L2 minus L1, whichever way you're doing it. And then to find the mean difference, you would be finding the mean from L3. And so for this example, that's why we would use a paired t-test and not the two sample t-test. Okay. And then the next topic is a really good like theoretical question. I'm not exactly sure like on what in like specific instances why we use pooled versus unpooled. These are kind of just givens that we're told. So you just need to follow along in the notes for specifics of when to use pooled and unpooled. It should always say in your calculator, or not in calculator, excuse me, in the notes when you're doing a specific test, if you're going to use pooled or unpooled. But I actually found like a research paper online called To Pool or Not to Pool. And I'm going to have that in the link in the description of the video so that you guys can read that if you're interested. If you're interested in the theory behind it or why certain things are done, then you can take a look at it. Otherwise, just refer to your notes of when to use the pooled and unpooled. Okay, and then the final thing we're going to cover is probability and discrete variable distribution. So I went into a lot of detail with this in exam 1, and I know it's been a while, but maybe go back and watch that video to see specific examples or, you know, get more details or anything you need. But for probability, the key formulas are the law of total probability and the addition rule. These are things that you're probably going to see often along with like independence and conditional probability. So just make sure you understand these laws and rules and how to apply them and stuff. And then the discrete variable distribution, I would hope you guys are pretty comfortable with that by now, considering you did the mini project and stuff. But basically, the definition of discrete variable is it's a finite number of values in a finite interval of its range. So kind of a common example you would see with that is the number of blank, whether it's like the number of scratches, etc. But really, like if you're thinking about a continuous variable, a lot of the time you would see something like electrical voltage, which in the range of like 0 and 1, you could have 0.0001 or 0.00000 repeating all the way to 1. So this is like an infinite range, basically. So that's an example of where it wouldn't be discrete. So just kind of go back. I know it's been a long time, but maybe review the exam 1 and exam 2 Muddiest points videos. Come to my office hours if you have any other questions. We can go over homework problems, but other than that, I hope this video helped you guys, and let me know if you have any questions. Thank you.